I'm Anil Kumar. Welcome back to our series on solving questions shared by you. Let me again thanks Lisa, our subscriber, for sharing this worksheet, and I hope its solution will help many others. So this is part 2. We have already solved first 5 questions in part 1. Let's now see how to solve question number 6. A factory worker pushes a package along a broken conveyor belt from minus 40 to 40 with a 50 Newton force at 30 degrees angle to the conveyor belt. How much mechanical work is done if the units of conveyor belt are in meters? So let's make a diagram here. So what we'll do is we'll again go back to our coordinate plane. We are saying that the worker pushes from minus 40 to 40, let's say from here to this point. So this is negative 4 and that is positive 4. So distance of 8 meters, right? Units are in meters with a force which is 50 newtons at 30 degrees. So the force is 50 newtons at 30 degrees. Okay. So let us say that is the force, right? And this force is at an angle of 30 degrees to the conveyor belt, and that's the conveyor belt, right? And the magnitude is 50 newtons. We need to find the work done. So work done is the force is a dot product F dot S, right? Force dot S. So when we say dot product, so we say work done W is the magnitude of force times magnitude of displacement times, you can write them like this as vectors, right? Or make them bold. But work done is a scalar quantity, right? And the angle in between, which is cos of 30 degrees. Since only the component which is along the direction of movement that really helps in the actual work being done, right? Now here displacement S is actually 4 minus 4, which makes it plus 4. So it is 8 meters, right? So that is the magnitude we're talking about. So we can substitute these values. So we have 50 newtons times, let's write brackets here, 8 meters, and the value of cos 30. So you can use your special triangle as we just did earlier, right? So I prefer to always make my triangle like this, in which the side here will be 30, correct? So 1, 2, square root 3. So the cos component is basically square root 3 over 2. Correct? So that becomes the magnitude, and the units will be Newton meters, or you can write joules, right? So that is the work done. So we can divide this. It goes 4 times 50 is 200. So we have 200 Newton meters times square root 3 Newton meters. We also use the units joules, right? So we can say work done equals to 200 square root 3 joules, right? So that is the solution. Let's move on and take question number 7 now. Determine the angle between the vector PQ and the positive, I think, positive x-axis, given endpoints P, 4, 7 and Q it should be. Okay, so I'm making a lot of typing errors. It's kind of difficult for me to do all this with broken hand. Okay. So we have the point 4, 7 and 8, 3. So basically, as you can see, 4, 7 and 8, 3 is a line which is coming downwards, right? 4, 7 and 8, 3. So we're talking about this. Okay. So we have this point P, which is 4, 7, and the point Q, which is 8, 3. Perfect. We need to determine the angle between the vector PQ and the positive x-axis. Well, think like this. Right. So you have to extend this to give you the angle. Now, whenever we say angle, which angle are we talking about? Is it this angle, that angle, out of these four? So clearly the angle which we are always saying is you have to put the vectors with their tails together and then find the angle. So that is the angle which you should be figuring out. Does make sense to you, right? Now this angle is actually equal to that angle. So the acute angle is what we are looking into. Perfect. So this is the acute angle which we are looking into. So to find the angle, let me just complete this triangle, right? So which is this angle. Is that clear to you? So from here we get the angle directly as tan theta, right? So we have the point P, which is 4, 7. We have the point Q, which is 8, 3. And from the diagram, we can say tan theta is basically equal to rise over run, right? So the rise is 7 minus 3 divided by the run, which is, in this case, 8 minus 4, right? This distance. We're taking this as positive, right? So it is 4 over 4, and which is 1. So theta is tan inverse of 1, and so it is 45 degrees. Correct? So some of you may just get the angle, this negative, right? However, it is very clear that whenever you're writing angle between the vectors, then it should be aligned, right? So let me write a note here. And the note is angle between vectors. Place tails together. Is that clear? So we have this x component, and then we have this component, which is the vector component of PQ. And that is the angle which you're looking for. Clearly, it's an acute angle, right? So we didn't really write the slope as we write in the line. I know the slope is negative, okay? However, in this particular case, we are looking into the other angle, which is the acute angle, right? So this we did for acute angle. So many times students may get this question wrong because they may just write 135 degrees, which will not be a correct answer, correct? So I hope that makes sense, right? Let's look into question number 8. Determine the value of k such that u and v are orthogonal. So we are given two vectors u and v, right? Orthogonal means perpendicular. Vectors are perpendicular if dot product is 0, right? So that's a note. So dot product is 0 for perpendicular vectors. Right. So that is what you should apply. So that should be simple now. So you can actually pause the video, answer this. So we are doing u dot v equals to 0. U is 413 dot v is minus 15k. And so when you do this, you get minus 4 plus 5 plus 3k equals to 0. So that is 1 plus 3k equals to 0. So 3k equals to minus 1, or k is minus 1 over 3. So get our answer. Right, that is relatively simple. The second part, let's again do the same thing. U dot v equals to 0. we have 11 3 2k dot k 4k. So that's a quadratic equation equals to 0. So we have 11k plus 4 times 3 is 12 plus 2k square equals to 0. Okay, let's rewrite this. So we have 2k square plus 11k plus 12 equals to 0. We'll use the quadratic formula, minus 11 plus minus square root of 11 square minus 4 times 2 times 12. So that's a quadratic formula, right? Minus b plus minus b square minus 4ac divided by 2a. And let's calculate this value. Okay. So within the square root, we have 11 square minus 4 times 2 times 12. And this is a critical number, which is 25. And square root of our answer is definitely 5. So we have 11 minus 11 plus minus 5 over 4, right? Okay. So we have one negative answer. So we have two answers here, right? So one is negative, and that is 16 over 4, which is 4, correct. The other one will be 11, I should have written negatives, and okay, let me do 5 minus 11, and then divide by 4. So it's a fraction, which is minus 1.5. Correct. You can also write this as 3 by 2 or 1.5 as shown here, right? So that is how we can get both our answers, right? Both are negative. So in this case, k has two values, which is minus 4 and minus 1.5. Is that clear to you? Right. So we have our answer, that is k equals to minus 4 or minus 1.5. And here we have k equals to minus 1 over 3, right? Find a vector that is orthogonal to both u, 2, 3, 1 and v, 4, 5, minus 2. Now, orthogonal means perpendicular, right? Now, in Unit 1, we don't really teach you cross product. So alternate solution will be using cross product. Since we have only done dot product, we need to apply dot product to get our solution, right? So we'll treat this as dot product application. Later in Unit 2, when we learn cross product, we can actually again answer this question using cross product. So we are given two vectors. One of them is u, which is 2, 3, 1. The other one is v, which is 4, 5, minus 2. Let us say w is orthogonal to both, and let's say we call it ABC. Now, if w is orthogonal, right, so then we have vector u dot w should be equal to 0. So that means 2, 3, 1 dot ABC should be 0, and that gives you 2a plus 3b plus c equals to 0. So we get one equation. So let's call this as our equation number 1. Now it also means that v dot w is also equals to 0, and that means that 4, 5 minus 2 dot ABC is equal to 0, and that gives you equation number 2, which is 4a plus 5b minus 2c equals to 0. So we get two conditions. Now from these two conditions, we need to find the value of a, b, and c. So we are solving these two equations. One is 4a plus 5b minus 2c equals to 0. And I'm going to multiply the first equation by 2. So I'll write that as 2a times 2 is 4a, 3 times 2 is 6, and plus c is plus 2c equals to 0. So what we did here at this stage was, this is our equation number 2 as such, and in this case we had equation number 1 times 2, right? So we multiplied the equation number 1 by 2 to eliminate c, right? Since we need to find the value of a, b, and c. Now let's add these two equations, right? So when you add them, you get 8a plus 11b equals to 0. We need to solve this equation now. So we can use parameters to solve. So it can have infinite solutions, you can see, right? So it has infinite solutions. It makes sense. You know, when you have these two vectors, let's say we have a vector u on this plane and we have another vector v, right? In that case, all the vectors which are perpendicular to the paper, right, will be perpendicular to them, right? Do you see that? So we say we have infinite vectors perpendicular to two vectors, right? Since on this plane every vector like this will be perpendicular and all are solutions. So we have a parametric solution here, right? So we call this as a parametric solution. We can substitute some values of a and b, right? So what we can do is, one solution could be we can take a as 11 and then b as minus 8. So then this equation is satisfied, right? Let's call this as our equation number 3, and equation 3 will be satisfied. If you substitute 11 for a and minus b as 8 minus 8 as b, you get 0, right? So we get these values. Now from here we can sub these values in equation 1 to find c, right? So sub in equation 1 to find c. So when I do, so this is equation 1, right? So we are now actually substituting these values back in our equation 1 to find c. Clear? So we get 2 times a is 11 plus 3 times minus 8 plus c equals to 0. So that is 22 minus 24 plus c equals to 0. And this is minus 2 plus c equals to 0. And that means c is equals to 2. So if we get the value of c as 2, then clearly we know what w is. So we can say that the vector w is basically equal to a is 11, right? B is minus 8 and c is 2. Is that clear to you? So we do get our vector. Now it is a good idea to check the result, right? So, do we have the right result? So let's check and test. It is important for you to understand that, we got one answer. There could be many. Let us at least test, right? So if I do dot product of w with, let us say, u, which is 231, what do I get? 11 to 22 minus 8 times 3, 24, plus 2. It is equal to 0. So that means that the vector, this is vector w, right? Dot vector u equals to 0. So that means they are perpendicular. You can do the same test with v also, right? So we have 4 5 minus 2 dot 11 minus 8 and 2. So that gives you what? 44 minus 40, and that is minus 4. And this is also equal to 0. So that also confirms that the product V dot W is equal to 0. Do you see that part, right? So it is kind of important for us to understand that there could be many solutions, and we need to estimate one value, figure out the other one, and then substitute those to get the third one. So like this, we can get many solutions for perpendicular vectors to two vectors, right? Now let's take the related question, question number 10. Now in question number 10, this is very similar to what we did in question 9. It is find a unit vector. So the difference is to find a unit vector that is orthogonal to these two vectors. I'd like you to now pause the video, answer this question, and then look into my suggestions. That will give you confidence of understanding the concepts learned. Perfect. So you can now pause the video, solve, and then look into my solutions. So I hope that you have understood the process. Let us repeat the process learned in question number 9 to get the concept once again. So we are given two vectors u and v. Vector u, we can write this as 3 minus 4, 1, right? Vector v is given to us as 2, 3 minus 4. And we say w is ABC. Now if w is perpendicular to u, then their dot product should be 0. So again, we'll do ABC dot 3 minus 4, 1 equal to 0, and we get 3a plus, rather minus 4b plus c equals to 0, and that is our equation number 1. Second equation we are going to get by writing dot product of v with w, and that gives you ABC dot 2, 3 minus 4 equals to 0. And the equation will now be 2a plus 3b minus 4c equals to 0. So we have now two equations. However, there are three variables to calculate. So we expect infinite solutions. To solve these two equations, we need to eliminate, right? So we will do equation 1 times 4. We can write this as 12a minus 16b plus 4c equals to 0. And then equation 2 is 2a plus 3b minus 4c equals to 0. This is our equation number 2, right? To eliminate c, we are going to add them up. Is that clear to you? So we get 14a, and that is minus 13b equals to 0. Easy solution could be a we can take as 13, right? And b as 14. So if you substitute, we will get 0. So if that is our solution, we'll call this as our solution as equation 4. We'll substitute this in 1, right? So sub in 1. So 13 3 times minus 4 times 14 plus c equals to 0. So let's calculate these values. So 3 times 13, which is 39, and from this we'll take away 4 times 14. So that gives us minus 17, right? So we get minus 17 plus c equals to 0, or c equals to 17. So we have the values for a, b, and c. Do you see that? And therefore, we can write down our vector, which is perpendicular to both, as 13, 14, and 17. Correct? Now that is the vector, not the unit vector. We need to now find the unit vector. How do we do so? Unit vector has a magnitude of 1, right? So the unit vector W will be the vector itself, the vector itself over its magnitude. Then we get unit vector. So in our case, the unit vector, which we write as W cap, is the vector which is 13, 14, 17 divided by square root of 13 square plus 14 square plus 17 square. Let's calculate this value. So the square root of 13 square plus 14 square plus 17 square. This is square root of 654. So we have this as 1 over square root of 654 times 13, 14, 17. Is that clear to you? So that becomes our solution in this particular case. Right? So we can actually rewrite this unit vector as 13 over square root of 654, 14 over square root of 654, and 17 over square root of 654. Does make sense to you? So that becomes our solution for the given question. So I hope that makes sense. So with this, we have done a great application of dot product to find the value of an orthogonal vector to two given vectors in R3. We complete solution of all the 10 questions of our worksheet, which was provided by Lisa. Let me thank her once again for sharing with us very important questions, and I hope this is going to help many others. So once again, that is the website which we are developing, Global Math Institute, and my email is provided. You can always share your test papers and worksheets with me so that I can provide solutions and explanation and upload the same on my website for future reference. This website will be used for all the students globally and will be free for them to have an access to these videos and the contributions of our students worldwide. Thank you once again. All the best.